and welcome to Cherry Pie Math. Today we're going to be introducing absolute values, and you might have seen these before, but this will just be a quick review then on what their definition is, but then also how we can apply that using PEMDAS. So to start off, let's look at a number line, and I have four things here. So we have 9 minus 5, 5 minus 9, 4, and the distance of 5 to 9. And so let's just go ahead, and I want you to pause the video and draw those on your own number line. So pause it. Okay, so, or maybe you didn't pause it, I don't know. I always say to pause it and then I don't even know if you do because you're watching it on your own. But, so let's take a look at 9 minus 5. So that one would be, we start here and we go 5 spaces this way. So 1, 2, 3, 4, 5. And we end up at 4 right here. Okay. And then let's try 5 minus 9. So that would be at 5 we would start and we would go 1, 2, 3, 4, 5, 6, 7, 8, 9. And that would bring us to -4. And then if we draw just straight up 4, that's just right here. And then the distance from 5 to 9, we've already kind of done that. It's over here. Or sorry, from 5 to 9. The distance is actually different. My bad. Let's do that in green. So that would be this part right here. So as you look at these, you might notice that all of these things have in common the number 4. For example, the first one, 5 minus 9, we actually equal to 4. 5 minus 9 is equal to -4. 4 is obviously just 4, and the distance from 5 to 9 is 4 spaces. So absolute value has to do with this. It's all about distances, and especially it's the distance from 0. So let's take a look at the definition and how that plays into it with and without the number line being physically drawn. So the definition of an absolute value is it's the distance of the value from 0. So for example, if I had the absolute value of, I don't know, 7, I would start at 0. And let me write 1, 2, 3, 4, 5, 6, 7. This is obviously 7 spaces away from 0. But then if I did the absolute value of -7, and that's over here, so -1, -2, -3, -4, -5, -6, -7, that's also 7 spaces away from 0. Yes, the -7 is the location on the number line, but the absolute value means we actually just care about the distance from 0. And as you can kind of see already, I've written the notation. The notation is a bar, and then the number, and then another bar. And I don't want to say number actually, so we'll say that for now. But really it just means whatever is inside of the absolute value. That's the notation. So instead of parentheses, we write bars. And that means we're looking for the distance from 0. So let's take a look at some examples. So the absolute value of 5, so let's write these again, would just be 5 because it's 5 spaces away from 0. The absolute value of 103, which is all the way over here, is 103 spaces away from 0. -8, I'll just write these real quick. -6, -7, -8 is 8 spaces away from 0. But distance is always positive, so this will always become positive. And that's the really cool thing about absolute values. That's why the definition of the distance from 0 matters so much, is because distance is always, always, always positive. So that's our fact about this, is that absolute values are always positive because distance is always positive. You never say negative distance. Even if you're traveling backwards, you're still traveling, right? Like if you're driving in a car and you put the car in reverse, you're still adding miles to your speedometer. Distance is never negative, so absolute values are always positive. So for example, the absolute value of negative 65, that's how we would read it, is we say the absolute value of blank. So in this case, it'd be negative 65. Would be positive 65 because the distance of negative 65 from 0 is 65 spaces. Another fact about them is absolute values act like parentheses. They're not exactly parentheses because in a normal parentheses you just keep the positive or the negative, whereas in absolute values you make it positive. But for the sake of PEMDAS, we treat them as parentheses, so we do the inside of them first before we do anything else. So, and this is a common mistake I'll see students make, and I'll explain that more in just a second. So, for example, here we have the absolute value. So you read absolute value of 5 plus 8. That's how you would, that's an S. 5 plus 8. That's how you would read it out loud. So 5 plus 8, because it's like a parenthesis, so we would do that first. That's the absolute value of 13, which is just 13 spaces. So that's how you do it, is you just do the inside of it first, and then you go from there. You do not apply the absolute value until you have finished making the inside into one thing. Otherwise, you're just going to get the answer wrong. So one thing my students would do is they would say, oh, this is negative. All I remember is that absolute values make it positive. So what they'll do is they'll write 6 plus 2, and then they'll say, oh, the answer is 8. That's wrong. It's a parentheses, so you need to do the inside first. Negative 6 plus 2 is negative 4. The actual answer for this is positive 4 because you do the inside first. Always finish like condensing the inside of the absolute value first before you apply the absolute value. So again, in this next one, we have 10 minus negative 3. And if you remember back to our lesson about PEMDAS, if you have two negatives, you can make it into a positive. So 10 plus 3 is 13. So again, this one is really just 13. Over here, PEMDAS first. There's a lot of things going on. But because we treat the absolute value like parentheses, we do this part first, and then we'll worry about that adding later because adding goes later in PEMDAS. So 9 minus 4 is 5. So we condense that first, and then I'm just going to copy it down. And the absolute value is 5. Now I can do 5 plus 1 is 6. And this next one, this one's a little bit trickier. You see that negative? It's outside of the absolute value. I want to make it clear, this negative absolute value of 32 is not equal to the absolute value of negative 32 because if you notice, the negatives are in different places. Since this negative is outside, it's not part of the absolute value. It's actually separate. So we would apply it after we take the absolute value of 32. So 32 becomes positive 32, right? However, that negative gets applied later, so the actual total answer is 32. So again, just to make that a little bit more clear, let me do this in highlighter colors. So the negative, or the 32, the absolute value of 32 became positive 32, this part here, okay? However, this negative stayed outside, so that's how it works. If you have a negative on the outside, it makes your final answer negative, but your absolute value is still positive. So let's do that one more time down here. So we keep the negative outside because it's not part of the absolute value. Now we do parentheses first. So 8 plus 4 is 12. We're going to keep the 12 inside, minus 2. And the absolute value of 12 is 12. But again, that negative is outside. So really we're doing negative 12 minus 2, which is negative 14. So if there's a negative sign in front of the absolute value bars, the result will be negative. Be careful about that. So watch out for those negatives and the location. If it's inside, the final you can just make it positive. well, okay, let me edit that. If it's inside like this, make sure you apply PEMDAS first and then take the absolute value. If the negative is outside, that negative gets applied at the very end and it makes your final result negative. So some things to remember: absolute value means the distance of the value from 0. So the absolute value is always positive. But it's applied after you finish solving the inside. Just like in PEMDAS, you would solve the inside first of the parentheses before you move on. So in absolute value, you do the inside first, and then you apply the absolute value. If there's a negative in front, it makes your final result negative. It's basically the multiplication step in PEMDAS instead of putting it at the beginning. I hope that helps. We're going to do a little bit more practice as we go forward, but I guess the main thing here to remember is absolute value is the distance of the value from 0, and it will always be positive.